Hello, welcome to week 8. Here we're going to talk about the cost volume profit relationship between products, price, and what you can sell them for. So one of the topics that we're going to cover is target costing. This ties into the break-even point and coming up with the best pricing for your product and how to control costs. So here we have a company that's interested in producing and selling a deluxe electric pencil sharpener. Market research indicates that the customers are willing to pay $40 for a sharpener and that 20,000 units could be sold each year at this price. The cost to produce the sharpener is currently estimated to be $34. So there's 3 parts to this question. The first part, if OnPoint requires a 20% return on sales to undertake production of a product, what's the target cost? So I'm going to flip between Connect and Excel. So after reading the book, we know that the target cost is the difference between your target price and your target profit. So here, our target price we know is $40. That's what we're selling the product for. And the target profit is going to be a 21% return on that. So 21% times our price, equals 21% times our price. So we want a return of $8.40. So that means the target cost is going to be the target price minus the target profit. So in this case, our target cost is $31.60. If a competitor sells basically the same sharpener for $36, what would OnPoint's target cost be to maintain a 20% return on sales? Sorry, it's 20%, not 21. My bad. So currently their cost is $34 and they need to reduce that to $32 in order to earn a 20% profit. We go through the same process to figure out the new target cost based on the competitor's price. So the competitor's price is $36. 20% return is $7.20. Therefore, our target price minus the target profit is going to be the target cost of $28.80. So think about it this way. If they're making a product that costs $28.80 and they sell it for $36, they're earning $7.20 on each product, which is the profit that they're shooting for of a 20% return. At a price of $36, OnPoint estimates that it can sell 23,400 sharpeners per year. Assuming target costs are reached, would OnPoint earn more or less profit per year at the $36 selling price compared to the original estimate selling price of $40? So here we would look at the target profit for each product. Under this scenario, when we're selling $40, we sell 20,000 units. And under the $36 scenario, we sell 23,400. So in order to calculate our profit, we would take our profit times the number of units. In this case, it would be $160,000. And here it's going to be 720 times 23,400, 168,480. So while we're earning less per product, we're able to sell more products because of the lower price. Therefore, we're earning $8,840 more at the target price of $36. Okay, so our target cost is $32 here. And our target cost here is $28.80. And OnPoint will earn more or less they will earn more. Okay, let's move on to a more comprehensive example. Here we're looking at activity-based management and target costing. In this example, we're looking at using activity-based management in order to calculate our target cost. So here we're looking at two different products, KAP1 and Quinn. KAP1 sells for $120 and Quinn sells for $220. The estimated cost and production data for the current year is as follows in that table. So we're given our direct materials, direct labor, and our estimated production. So typically there's three different costs that go into a product: direct material, direct labor, and overhead. So here we're not given our overhead, we're going to have to calculate it. The additional information that we have is that fixed manufacturing overhead is estimated to be $2 million and variable overhead is estimated to equal $3 per direct labor hour. And they desire a 15% return on sales for all of its products. So the first thing we need to do is calculate the target cost for both KAP1 and Quinn. So let's go back to our spreadsheet. So again, we're going to use the formula that our target cost is going to equal the target price minus the target profit. So we know our, sorry, let me just go here for a second. Sorry about this. So this is going to be for KAP1 or whatever the name is, and this is going to be for Quinn. I don't know where they come up with these names. So our target price for KAP1 is $120, and the target price for Quinn is $220, and that was given to us in the example. So if you go back to this is where I'm getting that information. We know that our target profit is a 15% return. So it's going to be 15% times my price. So equals 15% times my price. And therefore my price minus my profit gives me my target cost of $102 in this case. We're going to do the same thing for Quinn. It's going to be 15% times my price, and the difference between my price and my target profit is my target cost. So now I know that my target cost is going to be $102 for KAP1 and $187 for Quinn. So let's put that in here. So it was 102 and 187. So estimate the total manufacturing cost per unit of each product if fixed overhead costs are assigned to the products on the basis of estimated production units. Which of the products is earning the desired return? So you'll remember that I just stated that there's three things that go into our overhead costs. Our product costs: direct materials, direct labor, and then overhead. Here we have fixed overhead and variable overhead. So the first thing we need to do here is actually calculate our fixed overhead per unit. We're given it in total is $2 million. Okay, so our total fixed overhead is $2 million. I think I might have one too many zeros there. Yes, I do. And then we need to look at our total units produced. Okay, that's our cost driver. Basically what that means is that we're looking at our cost per unit produced. So the total units produced is going to be the 25,000 for KAP1 and 15,000 for Quinn. So it's 40,000 units. Okay. Oh, hold on a second. Alright, so that means that what they're saying is that for every unit that we produce, we're going to incur additional that's what's the driver of a fixed overhead. So 2 million divided by our 40,000 gives me $50 per unit. Okay, so now I know that my direct materials is $30 for KAP, 24 is direct labor. I have fixed overhead of $50 per unit, and my variable is $3 per direct labor hour. So we need to figure out how many labor hours each product takes, labor hours. So we know that our cost is $24 per labor hour here, and it's $12 per hour. So 24 divided by 12 is 2 labor hours. And for for Quinn, it's $60 divided by 12 gives me, I'm having trouble with gives me 5 labor hours. Okay? So that means my cost is going to be $3 times 2 labor hours, or $6 per unit. Here it's $50. It's the same for both products. And now it's 5 labor hours times $3 per hour gives me $15 per unit, because it takes me 5 hours to make each unit. Okay? So now I know my total cost per unit is going to be $110 for KP1 and $170 for Quinn. Okay, so 110 and 170. Which product is earning the desired return? Okay, well, we know that our target cost is $102, and this one is telling us that it's currently costing $110. Our target cost for Quinn is $187, and Quinn currently costs $170. Because $170 is below the target cost of $187, that means that they're earning above and beyond the target profit. KAP1 is actually costing more than the target cost, so they're not earning the target profit yet. So the product is, Quinn is currently earning the greater desired rate of return. Now it's asking us to look at the total manufacturing cost per unit if fixed costs are assigned to products on the basis of direct labor hours, and then which one is earning the return. So you can see that there's different ways to assign the fixed costs. Basically, what we're trying to do is come up with an allocation method and trying to figure out what's the best method to allocate these different costs. So in reality, what that means is we're trying to identify what's actually causing these costs to increase. What's the driver? What's the cost driver that we're using? So under the first scenario here, we used production, the number of units that we're producing. Now we're going to look at labor hours instead. So everything remains the same except for this fixed overhead section, okay? So I'm actually just going to create this again down here. And our fixed overhead is changing because we're going to base it off of labor hours. So you'll see that we calculated our labor hours here. Okay, this is per unit. So the first thing that we need to do is calculate our total fixed cost, which we know is $2 million. Then we need to calculate our total labor hours. So our total labor hours are going to be equal to 2 hours per unit times the number of units that we're producing plus the number of units of Quinn times the 5 hours per product. Okay, so that gives us a total of 125,000 hours. So $2 million spread over 125,000 hours gives us $16 per hour. So now we can calculate the rate of $16 per hour times the number of hours that KEP uses is $32 total cost. 16 hours per hour times the total hours that Quinn uses is $80 per hour. So now we have a totally different cost. $92 for KEP1 and $200 for Quinn. The reason that this looks different than our previous calculation is because we're using a different cost driver. Here, in this scenario, we're saying that the number of units is what's driving our cost. And because and hours, sorry, I'm getting confused. The number of units is driving our cost, and it's a flat rate. Here, in the next scenario, we're saying that the number of hours is what's driving our cost. And because Quinn uses that many more hours than KEP1, they're going to get a higher percentage of the cost. So now Quinn is over their target cost and KEP1 is under their target cost. So the answer changes here. This is going to be 92, this is going to be 200, and now KEP1 is earning the greater desired return. And finally, we're going to look at estimating the total manufacturing cost per unit for each product if activity-based costing is used for assigning fixed overhead. Okay, so here what we're looking at is instead of coming up with one cost driver, we're actually going to be looking at each individual activity that adds up to the total $2 million in overhead. So here's our different amounts. Of the $2 million, $400,000 of it is from machine setups, $600,000 is purchase orders, $500,000 is machining, $200,000 is inspection, and $300,000 is shipping to customers. For each of these cost drivers, so for each of these activities, we have a cost driver. Number of setups, number of orders, number of machine hours, number of batches, number of shipments, okay? The first thing we're going to do is we need to figure out the total of each one. So the total of each cost driver is here. Now we can calculate our rate. So our total machine setup cost divided by the total number of machine setups gives us a rate of 800. Total purchase orders divided by the number of purchase orders gives us 2,000. The 500,000 machining divided by 8,000 machine hours gives us $63 per machine hour, and so forth. 2,500,000. Okay, so this is per setup, per order, per machine hour, per batch, and per shipment. Okay, so instead of just one rate, now we have 5 different rates. And in order to calculate our costs, we need to do it based off of these 5 different rates. So let's do that over here. We're going to have, these are going to be our different fixed overhead costs. Just give me a second. Okay. So we're simply going to take the rate times the number of setups for each one. Rate times number of orders. Rate times machine hours. Rate times batches, and rate times shipments. So you might see I pressed F4 to put these dollar signs in front of the number. What that means, when there's a dollar sign, that means that it's always going to direct to column number N and row 7. So now I can just copy this formula over, and you'll see that it kept the rate and just moved over to the Quinn side. So now we have our total costs for the products. Okay, so our total fixed overhead is $910,000 for KAP1 and $1.9 million for Quinn. This should always equal your total. In this case, it's the $2 million. Now to get our cost per unit, we divide it by the number of units. So here we're going to divide by 25,000 for KAP1, and this one's going to be divided by 15,000 for Quinn. Okay, and now this is our fixed overhead cost per unit. And now we can do our total product costs. Okay, so 30, 24, oops. Our fixed overhead is going to come up from up here, which we just calculated. And our variable overhead is the same as before, based on number of hours. And now we have our total product cost. So in this case, we've allocated the fixed overhead based on the actual activities that are creating the costs. So typically this is a more accurate method, and we're able to use it when we have all of the information available to us. So in this scenario, we're going to compare these to our target cost that we originally calculated here. So KAP1 is 102 target cost versus 96.40, and 187 versus 192.67. Therefore, KAP1 is earning the higher desired rate. And this is going to be 96.40, and this is 192.67. I'm going to pause the video here. The rest of the problem is just repeating the same process and tweaking some of the activities for changes in assumptions. So hopefully this helped you understand activity-based costing and target costing. Please let me know if you have any additional questions.